Hey everybody, welcome to lecture number 61. We'll do some review for chemistry. Okay, I just worked out a couple problems and we can do them together. You can stop it and figure everything out because it's so easy, isn't it? All right, let's look at the first one, okay? Find the mass of zero point 0.2 moles of mercury 3 sulfate. Remember, this is the stock system. So I'm telling you the charge of mercury, it's plus 3. Sulfate, remember, is minus 2, is the oxidation number. I'm telling you that mercury is 3. So this now will donate 6 electrons, 2 times 3 and 3 times minus 2. It will take, the sulfate will take 6 electrons, three sulfates. Okay, so this is my formula for mercury 3 sulfate. That's the first step, right? Next, we need to get the mass. So what do? We look at the mass of mercury, Hg. We have two mercuries, so we take 2 times periodic table, 201. You check my results. We have 3 sulfates, so that means there's 3 sulfurs. Sulfur is 32. And then we have 3 times 4 is 12 oxygens. So we have 12 times the mass of oxygen, which is 16. When I add these together, again, check me, don't trust me. I have 690 grams per mole, okay? And I want zero point 0.2 moles, right? So I just multiply zero point 0.2 times 690 grams per mole, and my answer is 138 grams for this problem. If I should ask how many uh, mercury atoms are there? Well, there's zero point 0.2 moles, which is zero point 0.2 Na. Each molecule has 2 mercury atoms. So it's 2 times zero point 0.2 Na is zero point 0.4 Na. When I multiply zero point 0.4 times 6 times 10 to the 23rd, I have 2.4 times 10 to the 23rd mercury atoms. Okay? Same for sulfur atoms, right? We said we have 3 sulfur atoms. So we have zero point 0.2 moles, zero point 0.2 Na times 3. So we get zero point 0.6 Na, zero point 0.6 times 6 times 10 to the 23rd, and that's 3.6 times 10 to the 23rd sulfur atoms. Huh? And finally, we have our oxygen atoms, zero point 0.2 moles, zero point 0.2 Na times 12. Remember, 3 times 4 is 12. So it's 12 uh, 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 times zero point 0.2 times 6 times 10 to the 23rd. And I come up with 6.44 times 10 to the 24th oxygen atoms. Okay, let's do one more of these. All right, not so bad. Periodic table, a calculator, and knowing oxidation numbers. All right, 60 grams of hydronium phosphate is how many moles? Hydronium phosphate. Remember hydronium, one of our positive polyatomics. So hydronium had a charge of +1. Remember the phosphate ion had a charge of -3, so it takes one phosphate ion, PO4 -3. You need 3 hydroniums. Okay, so I think my formula is correct. Once again, we need the mass, molecular mass, or molecular weight, or whatever you want to say. It's really mass because it's in grams. Let's count. All right, we have 3 hydroniums, which means we have 3 times 3 is 9 hydrogens. 9 times 1, the mass of hydrogen. We have 3 oxygens. I'm going slow. 3 times 16. We have 1 phosphorus, right? That's 31. And then we have 4 more oxygens. So 4 times 16. When I add them up, I get 152 grams of hydronium phosphate makes 1 mole. So 60 grams is what I'm interested in. Clearly, 60 grams is less than a mole. How much less than a mole, right? Well, it's 60 grams divided by 152 grams per mole. Okay, grams go out, and I'm left with, this is what I get, 0.39 moles or 0.39 Na. Once again, if I ask you how many hydrogen atoms, 3 times 3 is 9, so I have 0.39 Na times 9 hydrogens per molecule, When I multiply this, remember Na is 6 times 10 to the 23rd, we get 2.1 times 10 to the 24th hydrogen atoms. How many oxygen atoms? Well, if I want oxygen atoms in the entire molecule, I need to add up all the oxygen molecules. So I have 3 oxygens here and I have 4 here. So I have a total of 7 oxygens in hydronium phosphate. So 0.39 moles is 0.39 Na times the 7 oxygen atoms per molecule. 7 times 0.39 times 6 times 10 to the 23rd, and I get 1.64 times 10 to the 24th oxygen atoms. And finally, phosphorus, right? We only have one phosphorus atom in hydronium phosphate molecule. So we have 0.39 moles, 0.39 Na times 1, 0.39 times 6 times 10 to the 23rd, and we get 2.3 times 10 to the 23rd phosphorus atoms. Okie doke, that's not so bad. All right, we have a couple of balancing here. So why don't you take a look and try to balance them, and I will also try to balance them, okay? Let's see. There's a 1, I think, and a 6. So let's see. I have 2 irons. I have 2 ions. I have 2 times 3. You see the 3? 6 bromines. 6 bromines. 3 times 2 is 6 hydrogens. 6 times 1, 6 hydrogens. 3 times S is 3 sulfurs, 3 sulfurs in this phosphate ion. 3 times 4 is 12 oxygens. 3 times 4 is 12 oxygens. That one looks good. Okay? Okay, let's look at this one. Let's see if I did that one correctly. All right, let's count hydrogen, shall we? 4 times 2 is 8. 4 times 2 is 8. So I'm starting with 16 hydrogens. Therefore, we must finish with 16 hydrogens. Okay, here we have 8 hydrogens. Here we have 8 hydrogens. That's 16. Good. Count the silicons. 4 silicons, 4 SIs. There's 4 SIs here. That looks good. Chlorines. 4 times 2 is 8. There's an 8 in the hydrogen chloride right here. And what else? Oxygen, 4 oxygens, 4 oxygens. Okay, that one looks good. Let's look at this long one. Okay. Uh, let's see if this balances it. All right. Let's count. I have a 1 in front of this molecule. We have 5 carbons. Go on the right side, there's a 5. That's good. Let's count hydrogens now. Hydrogen's a little more complicated. We have 8, and 2 is 10, and 2 more is 12 hydrogens. So let's see if we have 12 on the right-hand side. Oh, look, we have 12. 1 times 12. Hydrogen's good. Oxygen 8. And what do we have here? Uh-oh. 8. Doesn't look good, does it? Doesn't look good. This is not balanced. This is not balanced right now, is it? Uh, 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 uh. We need 8 oxygens on the left. We only have 2 here. Oi, 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 oi. Oi, 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 oi. This could be complicated. Let's see. If I try putting a 4 here, all right, I would need a 4 here. So now the carbons are 20. The oxygens, nope, 32, no good. All right. All right, I got to work on that one. I'm not going to do it live, so I'm just going to erase and work on it, okay? I thought I could do that one quick, but I couldn't. Sometimes you got to pay attention and spend more time. Okay, I'll work on that one. Let's see. Potassium nitrate. This looks like if it was aqueous would be carbonic acid. Okay. Uh, let's look at the potassiums. Let's see if this works. Let's see if I can do one here. Two potassiums, two nitrogens, two nitrogens, six oxygens and three oxygens are nine oxygens. Three oxygens and six oxygens, nine. That's good. One carbon. What am I doing? Am I missing a carbon? K H2C. What? I think I wrote another wrong reaction here. I think I'm missing a term. Boy, boy, this is good. I don't know what I missed when I wrote this. Okay, I didn't have my coffee. All right, let's try one more. All right, let's try this. Um, BF3 boron. Let's see. Let me make sure I get this right. Okay. Okay, let's hope, let's keep our fingers crossed this one's correct, okay? Let's look at the boron, two, two times three is six fluorines, three times two is six lithiums. We did the borines. We have three sulfurs, good. Three times three is nine oxygens, three times three is nine oxygens. Yay, yay, I did one, okay? Sorry about that. I have to pay more attention. All right. So balancing, again, we know the idea. Same number of each element on each side. Okay. Let's see. Let's see. Let's see. Okay. Let's erase. And let's try to do these naming, shall we? All right. Lead 2 nitride. All right. Lead 2 is Pb. Has a +2 charge in the stock system. Nitride is just the element, remember, so it's N. N is in group 5, so it has an oxidation of -3, so we need 3 of these and 2 of these. Okay, and I'll erase this. And there's our lead 2 nitride. Aluminum cyanide, you should know by now, aluminum +3. Cyanide was the polyatomic ion, Cn -1. Clearly, we have one aluminum and three cyanides, yeah? So we'll just erase, take this away, and there's our aluminum cyanide. Hydronium, one of our positive polyatomic ions, H3O. Remember, we had a +1 charge. Sulfite, what was sulfite? Sulfite was what? SO3 -2, I believe, correct? So we need two hydroniums and one sulfite. So I'll take this away. I don't need a parenthesis around the sulfite. And that looks like hydronium sulfite. Strontium, our old friend strontium, group 2A, right? Strontium, Sr +2. Phosphate, our old friend, PO4 -3. So we need three strontiums, two phosphates, and there we go, strontium phosphate. And finally, cupric nitrate. Cupric, what is cupric? Remember, cupric was Cu +2. When copper had a +1, it was cuprous. So cupric is Cu +2. Nitrate was NO3 with a -1. Is that correct? So we need one copper and two nitrates. So we can take this away, and there is not copper nitrate, but copper 2 nitrate or cupric nitrate. Okay, fantastic. Let's name these. Can you see? So we have C2H2, right? Two carbons, MEPB. Remember me peanut butter. So this is S. 2N minus 2, right? So this is ethine. C5H11. Whenever there's an odd number, remember it's an eel. 5 is pent, so this looks like pentyl. C8H16. So this is N is 8, 2N is 16, N 2N is an ene, double bond. 8 is oct, so this should be octene. It's good. C6H6, be careful. C6H6 doesn't follow any of our formulas for alkanes, alkenes, alkynes, alkyls. Doesn't follow any of the formulas. So what is it? Oh, this is just our benzene. Remember benzene. We'll do that. And we there's a carbon at every corner, remember? And we stick an H. So there's our C6H6. And then we did various additions. Okay. Um, C3H8. Okay. MEP, this is a prop. 2N plus 2, N is 3. 2 times 3 is 6, plus 2 is 8. 2N plus 2 is an alkane, MEP, so this is propane. You remember where propane is used? In a gas tank to do your barbecuing. And finally, I wrote C7H12. N is 7. 2 times 7 is 14. Minus 2. 2N minus 2 is an ine. 7 is hept. So this should be heptine. Okay? All right. Now we'll look this quickly. This organic molecule. So let's see what we have. I'll redraw it here. Double bond. I'll just put CH3 here. Has to be a CH2. Okay, that should be a CH2. Okay, CH2. Okay, good. So this really is this. Okay. What else do I have? So I have this and a C2H5, and I have an H and a C2H5 here. What is that? Do you know what that is? Ethyl, right? H and a CH3 methyl. All right, let's find the longest chain, but we must involve the double bond in our longest chain. So we have 1, 2, 3, 1, 2, 3, 4, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 7. Look at that. 1, 2, 3, 6, 9. Okay? So if you see this is this is the path we're going to go. Everything else is an addition. The double bond is on 1. We said 1, 2, 3, 9. So this is a no 9. With the double bond on carbon 1. So it's a 1, no 9. Okay. This methyl is not part of the group. And what else is not part of the group? All this crap is not part of the group. What in the world is this addition? Well, let's count. 1, 3, 4, 6, 5, 8, 13. Did I do this right? 14, right? This should be 13. C2H5, CH3, C2H5, H5. Wow. Should be 13 here. Did I count wrong? This should be hexyl. And there's a methyl. 1, 2, 3. 3 hexyl, 2 methyl. Okay? 3 hexyl, 2 methyl. All right. Looks okay. Okay. Let's see. Let's try. Let's try this. 3, 1. So this has 3, 1. Oops. C3H7. There we go. Let's see. So this makes 4 bonds. This carbon makes 3 and 1, 4 bonds. This carbon makes 4 bonds. Everything looks good. So we have to find the longest chain. We have to include this 4, 5, 6, 4, 5, 6, 7, 8. Oops. Oops. How's that? 4, 5, 6, 7, 8, 10. Right? We're not going over 10 for us. All right, so it looks like a decene because there's a triple bond. If I count from here, that's 2, 3. It would be on carbon 4 if I count it that way, the triple bond. If I count here, 4, 5, 6, it would be on carbon 6. So I need to count this way. Okay, 2, 3. So this would be carbon 4. So it's a 4 decene. This good? And there's my methyl. So that's carbon 4, carbon 5. This would be carbon 6. So it would be a 6 methyl 4 decene. Okay, got to watch which way we count. All right, let's do one more. Let's see. I'll just draw a bunch of C's here. Bunch of CH3s. How's that, huh? We'll just invent stuff. I got to make sure I count correctly. All right. All right, here we go. Did I put all the H's in? All right, let's count. 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 3, 4, 5, 6, 9. Okay. All single bonds. There's my chain. Okay, so it's a nonane. It's good. So if that's my chain, then that methyl's not part of it, that methyl's not part of it, that methyl's not part of it. And what the heck is this? C3, 1, 2, 3, C3H7 is what? What is C3H7 MEP? That's propyl. All right, which way we have to count now? It's a no name. I'll write it down here. No name. All right, so we have methyl, methyl, methyl. Which way are we counting? And a propyl. All right, so if I count from here, that's carbon 3. This would be carbon 4, 5, 6. If I count this way, this would be carbon 4. I'm going to count this way. 3, carbon 4, carbon 5, and carbon 6. Okay, so now we can count. This is carbon 3. We have 4, 4. And then on carbon 5, we have 4, 4, 5, trimethyl. Okay, so we took care of the methyls. And here we have what? What do we say? We have propyl. Propyl was on carbon 5, so it's a 5 propyl. So you check that, make sure it's okay. When you're right next to the board, sometimes it's a little tricky to see. But I think that's right. 4,4,5, trimethyl, 5 propyl, no name. Okay, no name. My longest chain was 9. Okie doke. Do you remember the name of this molecule? This is my benzene, and we said this. So this was either methyl, benzene. Do you remember another name for it? It was toluene. So methylbenzene is the same as toluene. Okay? So let's just say I put something like this, bromine here. Okay? Well, I could name this a couple things. Bromine, methyl, right? So it would be 1 bromo, 3 methyl benzene. That's correct. Okay? I could call it, because you skip one, I could say meta bromo methyl benzene. Remember, when there's 2 additions to the benzene, and you skip a bond, it's called meta. Meta, that's an E. Or you could say it's just, they say sometimes M bromo methyl benzene. They don't even say meta, they just write it as M. What if I want to call this toluene? So the methyl group defines it as toluene. That automatically makes this carbon 1. Okay, so I could say meta bromo toluene, or just M bromo toluene. Okay, so a lot of names for this silly molecule. All of them are correct. Okay, let's try another ring. Let's just do another ring. So when there's two additions, you can use 1 and 2, 1, 3, 1, 4, 1, 5, whatever you want, or you can use the ortho, meta, and para. Okay, you could use either one. When there's more than 2 additions, then we have to just do it alphabetically. Okay? All right, C6H13 is what? Hexyl? Ethyl? Fluorine? So it looks like E comes before F, comes before H. So this would be on carbon 1. So this would be a 1 ethyl. 1, 2, 3 fluoro. 4, 5. 5 hexyl benzene. Okay, very straightforward. Ethyl E comes before F, comes before H, so I make the ethyl on carbon 1. I could go the other way. If I went the other way, this would be carbon 1. It would be 5-fluoro and 3-hexyl. These would be switched, but I think 135 is lower. Okay, let's do another one. Not so bad. There's a not so bad. Oh, let's look at this one. We have methyl, methyl. You know what 4 is? MEPB. This is a butyl. So if we just go in alphabetical order, this would be on carbon 1. It would be a 1-butyl. You can go either way. I mean, you need to go this way. Sorry. 2-methyl. Sorry. 2, 3, 4, 5. 2,5 dimethyl benzene. So let's say this again. There's my butyl on carbon 1. Methyl is on carbon 2, 3, 4, 5. So it's a 2,5 dimethyl. Okay, that looks good. What else can we call it? Well, we can call it toluene. All right, if I call it toluene, because that's next to that, that's going to be my carbon 1. That'll be my carbon 2, 3, 4. So now if it's toluene, butyl, it's 2-butyl, oops, 2-butyl, 4-methyl toluene. So if I call this toluene, and you say, why did you use this methyl as opposed to this methyl? I use this methyl as opposed to this methyl to define it as toluene, because by defining it this way, then the butyl would be on carbon 2, which is a lower number than if I define this as the toluene. Then it would be carbon 2, it would be a 3-methyl, 3-butyl 4-methyl. Okay, so it's lower number if I define this methyl as the toluene. Okay. Mhm. So let's do another chain. Mhm. Uh, all right, let's look at this one. Did I do everything right? Well, carbon has 4 bonds. That has 4 bonds. This has 2, 4. This has 2, 4. This is my C2H5, my ethyl. Everything looks good. So we have a double bond we need to get in here. So the ending is ENE. And let's see the longest chain. I'm going to guess from here. 4, 5, 6, 7. 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9. Okay? All right. So this is my chain. That's not part of my chain. That's not part of my chain. That's not part of my chain. 4, 5, 6, 7, 9. So it's nonene, nonene, double bond. Which way shall we count? If we count from this end, that's carbon 4, carbon 5. The double bond would be on carbon 5. If I count from this side, 2, 3, 4, right? This would be on carbon, double bond would be on carbon, so it's a 4 nonene. I'm going to count this as carbon 1, carbon 2, carbon 3, carbon 4. So, what do we have here? We have ethyl, okay? So we have a 4 ethyl. There's a methyl. So we have 4 ethyl. That's that guy. And there's a methyl, and there's a CH3 of methyl. So it looks like this methyl is on carbon 2. This methyl, right, is on carbon 3. So we have a 2,3 dimethyl 4-nonene. Okay, so if you saw this on an exam, if you saw this picture on an exam and you had to name it, what I do, the first thing I do is I see a double bond. If I see a double bond, I look for anything that has an ENE ending. Okay, ENE, because it's a double bond. The second thing I do is I look for the longest chain. Here you need to be careful. I make mistakes. You can make a mistake. You have to be very careful to try to go every single path. Try every path. But when you have a double or triple bond, you must get that double or triple bond in there. Okay? 4, 5, 6, 7, 8, 9. There was my longest chain. And then what I do, and you can do it with, well, if you have a paper, you can do it in colored thing. I always circle my additions. And again, for this one, if I count this way, we said the double bond was on carbon 4. If I started from this end, it would be on carbon 5. So 4 was lower than 5. So I must count that way. Once I count that way, you see that the ethyl, right? The ethyl was on carbon 4. 1, 2, 3, 4. And the methyl was on carbon 2 and on carbon 3. Okay? All right. Take care, enjoy, be safe, and see you next time.